Hello people, in this video I would be showing you how to find the state model of the electrical circuit given below. Now the electrical circuit given here is having Vi as the source, R is the resistance over here, L is the inductance and C is the capacitance, and Vc is the voltage across the capacitor, and IL is the current through the inductor. Now let us start by drawing a small model which represents the circuit. The input is Vi, the output is V0, which I can represent it as Y, and the state variables are x1 and x2, which are IL and Vc. The reason why only these two are the state variables are, we term that the inductor and the capacitor are termed as the memory elements of the circuit, because the current through the inductor and the voltage across the capacitor can be taken as the state variables. This represents the system. Once the basic system is ready, now the state model equation is of the form that is x dot, that is a state model should be equal to A into x1 x2, because there are two state variables, plus B into the input. Here it is Vi, I can represent it by U. Okay, once I'm done with it, the output equation can be represented as Y is equal to A into x1 x2 plus B into U, where U represents the input. Now as you observe that the output is dependent only on Vc, that is only on x2, I can write it as, I decide this matrix A to be Y is equal to, the matrix A becomes 0 1. Why 0? Because the output equation does not contain IL, which is a state variable x1. Therefore, since it contains only x2, that is Vc, I have written 1 here so that when I do the matrix multiplication with this, I would be getting only x2, that is Vc, plus 0 into U, which is the input. This is how the output equation of the state of the given circuit can be written. Now let us write the state variable, that is this equation, state model equation. Now how do we write it? The x1 dot represents dIL by dt, because IL is x1. Okay, similarly x2 dot is always equal to dVc by dt, because x2 represents the Vc. So now I can proceed by applying the KVL for the given circuit. Applying KVL to the given circuit, I can write it as Vi is equal to IL into R plus voltage across the capacitor is given by L into dIL by dt, okay, plus voltage across the capacitor, I directly write it as Vc. Now I observe that IL and Vc are the state variables directly, whereas the dIL by dt represents the state model. So therefore I can replace it by, I replace Vi by U because it represents the input, and I get ILR and Vc onto the LHS. So it becomes minus, IL can be written as x1 into R minus x2 whole divided by, this L comes to the denominator and that becomes x1 dot. So this forms one equation. Second equation can be formed for the x2 dot in the following process. That is, I can write IL, that is current through the capacitor, is always equal to capacitance C into differentiation of dVc by differentiation of the voltage across the capacitor. Using this equation, I know that IL is nothing but x1. Then the C, if I take it to the denominator, I get dVc by dt can be represented as x2 dot, and then now that I have got both the state model equations, now I have to represent it in the matrix format. Now let us see how to represent it in the matrix format. Now that we have obtained both the equations for the state model, I can represent it in the form of a state model equation where I represent the state model x1 dot and x2 dot here. That should be equated to a matrix, a 2 cross 2 matrix. How do I know that it is 2 cross 2? Because there are two state variables, hence I know that this matrix should be of 2 cross 2 multiplied by the state variables x1 and x2 plus the input U. So this and this is represented by a matrix. Now let us find what are the values of the matrix. Now observe that when you find the value of x1 dot, in the x1 dot expression, U has got 1 by L as the coefficient, correct? So therefore I represent 1 by L over here, okay? So that when you multiply U and add with it and add with this term, in that case you would be getting the x1 dot expression correctly. Now when you equate the next term, you find x1 as a state variable which has got the coefficient minus R by L, okay? So x1, when you put, you have got minus R by L, and x1 dot expression has got x2 with a coefficient minus 1 by L. So I write minus 1 by L over here, so that when you multiply you would be getting back this expression. Now in the next case, for the expression of x2 dot is having only x1 with a coefficient 1 by C. So I put 1 by C over here and 0 here because there is no x2 term here, and 0 here as well because there is no input term. So this is how you would be solving the state model for a given electrical circuit problems. Thank you for watching the video.